Today, in this video lecture, we will see shear force diagram and bending moment diagram of this frame structure. Previously, in our previous 15 lectures, we were seen that beam SFD BMD. Now, we will shift toward this frame structure. This is frame structure and this is free body diagram of frame structure. Now first understand this frame structure. At point A there is hinge support. Due to this hinge support, this AX and AY reaction comes at location A. Now at point D, this is roller support. Due to roller support, vertical CY reaction comes. See this element AB, vertical element. On this vertical element AB, there is 5 kN per meter uniformly distributed load acts. And total length of this AB is 5 meter. Now see this BC element. Total length of this BC element is 4 meter and a load acts 10 kN downward. And this CD element, there is no load. Length of this CD element is 5 meter. Now first judge shear force diagram of this frame structure. So see, due to this A reaction, some shear generates, AX shear generates at this point A. So this is like this. If this AB element is like this, just see this element like our beam AB. Although it is vertical, just see it like this. This is AX. This UDL is 5 kN per meter. And see here at point B, there is fixed point B. So due to this fixity, some vertical, horizontal and movement generates. So this is downward, that's why here negative shear generates. And see here uniformly distributed load. So uniformly distributed load, that means inclined line. So this is like this. This is positive. Now this BC. This BC is C at middle from point B to 2 kN, 2 meter, 10 kN load acts. So, and deflection of this beam is, so sorry, don't consider here deflection. See at point B there is some shear generates. At middle, due to this 10 kN, it drops down, and again here it is like this. As per my judgment, this is like this. We will see exact value and exact shape later. Now at point D, there is only CY reaction. So here no shear generates. Because there is no load in between D to C, only this CD is only like this. Here at point D, at point C, CD, at point C, 3 reaction comes. and at point D it is Cx. So it is here at portion CD no shear generates. Now thought about bending moment. Bending moment diagram. At point A, zero bending moment due to pin supports, and due to this 5 kN UDL, there is parabolic curved line for this bending moment diagram. So this is like this. This is positive, this is negative. Now this thought about this BC portion. B is also fixed and C is also fixed. So in between this there is no load. So this is like this, negative, negative. And at point D there is 0, but at point C some movement. So C there is also no movement generated. C at point C some movement generated. So this movement is like this. Now calculate exact values. For that, first solve the reactions. Summation of forces in x direction equal to 0. See, x direction forces this Ax and this 5 kN per meter acts on 5 meter distance. So positive 5. Consider this direction as positive and this direction as negative only for reaction calculation. For SFD and BMD, this is not like this. So for reaction calculation, Ax is positive and 5 into 5, positive 5 into 5. This is Ax, positive 5 into 5 equal to 0. So positive Ax is equal to minus 25 kilonewton. So this C, this is minus sign. Minus, that means this Ax is not like this. This Ax arrow is, correct arrow is like this. If this Ax comes positive, then this Ax is as it is, but when it comes negative, then reverse this arrow, reverse this reaction. Now take summation of forces in vertical direction equal to 0. See this AY, CY vertical and this 10 kilonewton downward. Vertical force positive downward force negative, positive AY, positive CY, 10 is downward, that's why minus 10 equal to 0. So positive AY, positive CY equal to 10 kilonewton. Now take moment at point A. Why take moment at point A? Because when we take moment at point A, then this CY we will get. And when we get this CY, put this CY in this equation, AY plus CY equal to 10. Then we get AY. So for that, first consider this 5 kilonewton meter movement. Summation of movement at point A equal to 0. So this A point. Now this 5 kilonewton meter UDL is C, clockwise to that point. Clockwise to that means this is goes through that point clockwise. So 5 into total length is 5 into 5 is UDL and total length is 5. That means 5 into 5 concentrated point load acts here and at middle of this beam. That means this distance is 2.5 meter. So 5 into 2.5, positive 5 into 2.5. Now see this 10 kilonewton. Perpendicular distance between this point and this 10 kilonewton is 2 meter. So force into that distance between point and load is 2 meter. Perpendicular distance between that point and load is 2 meter. So and this is also clockwise to that point. So positive 10 into 2. Again, now see this CY. This CY is anti-clockwise to that point. So anti-clockwise, that means minus sign. Remember, clockwise is positive and anti-clockwise is negative. So minus CY into distance between that point to force is, perpendicular distance between that point to force is 4 meter. So minus CY into 4. Equal to 0. Just see, consider all forces or not. See this UDL consider, 10 and CY consider. So okay. So this CY equal to, solve it by using calculator. Positive 5 into 2.5, positive 10 into 2, negative CY into 4 equal to 0. So it is 8.125 kilonewton. Now put this CY in this equation, AY plus CY equal to 0. If we put this 8.125 kilonewton, that means 10 minus CY, 8.125, it is 1.875 AY. AY reaction is 10 minus CY. 10 minus 8.125 is 1.875 kilonewton. So See how mistakes happens while solving this moment and all this. We consider here, see this force 5 kiloton per meter is UDL, and at a distance of 5 meter, this total length of this beam is 5 meter. So this 5 kiloton per meter UDL, and this acts on this 5 meter distance. So how to convert this into point load? Multiply this 5 kiloton meter and this distance acting on this beam, 5 meter beam. So 5 into 5 is this concentrated point load, and it acts at center of this beam. Center of this beam is 5 by 2. 5 by 2, that means 2.5 meter. And here see, while calculation of moment, we take only 5 into 2.5. We need to consider this as a 25. This is not 5, this is 25 concentrated point load. That's why our CY comes wrong. So here 25. So corrected CY is positive 25 into 2.5, positive 10 into 2, minus C into 4 equal to 0. So it is 20.625 kilonewton. Now put this 20.625 kilonewton load, 20.625 kilonewton reaction in this equation. So 10 minus 20.625, it is minus 10.625. So AY reaction is minus 10.625 kilonewton. So minus comes, so change this AY arrow also. So this AY is downward. This. Now AX is minus 25, AY is minus 10.625, and CY is 20.625. Now calculate shear force calculation. So for that, first consider this element, this AB element. Now see this AB element and draw free body diagram of this AB element. First see here at A, two reaction comes. Vertical, sorry, here see corrected downward AY and this AX. This is AX. The value is 10.625. And AX is minus 25. That means magnitude is 25 kilonewton. So see this A by 10.625 kilonewton, and at this point B there is fixed. Here this element is fixed, so every action there is equal and opposite reaction. So this AY, here AY comes vertical, this is downward, so this is vertical. This AX is 25 kilonewton, so we need to find here shear also. Let's consider this as Vx, and we need to find here moment also. Just see this beam like horizontal beam. This is A point, this is B point, this is AX vertical, this is AY axial load, this is AY axial, this downward is Vx. Take positive sign convention here, so this is anti-clockwise, EMX. This is positive sign convention, that means this arrow EMX is anti-clockwise, and here it is UDL 5 kilonewton per meter. Just for solving purpose, see like this vertical beam, see like this. So how shear generate here? See, this is vertical, this X, see this X, see this X, this goes upward, that means positive. Our objective is to solve for that. So here Ax goes here, so positive, and Ax is 25 kilonewton. See, in between this Ax is positive 25, this 5 kilonewton is, see here, this is downward, so downward, that means minus, see, minus, and 5 into 5, 5 is UDL and 5 is total length of this beam. We need to calculate at this point also shear at this point. So positive 25 minus 5 into this 5 UDL and this distance 2.5. So here 12.5. It's the UDL, that means shear is inclined angle. 5 at this point 12.5. Calculate at this point also shear. So see, positive 25 minus 5 into 5 is 0. Yes, this is like this. And our judgmental is, see, our judgmental shear force is wrong. This is like this. So let's delete this. Okay. This is shear force for that element, AB element. Now calculate shear force for that BC element. BC element is horizontal element, so 10 kiloton load here at middle. And at the distance of 2 meter and 2 meter. So see this is see this point here, shear is 0. So here at point B also, this is vertical, shear is 0. Let's see it. Vx is 0. See this AY is vertical upward. So see here, see this is frame structure. That means this is like this structure. So here AY is upward. So for this beam, this AY is like this, downward. So here take AY, not take Vx is equal to 0. Take downward AY. Why downward AY? Because for that AB element here axial force is upward AY. So here for that point BC, this is downward AY, and we know AY magnitude is 10.625 kilonewton. So take similar magnitude. See this Vx is 0 here. So here this Vx is equal to 0 kilonewton. And see moment also 0 here. So here also moment is 0. Moment equal to 0. Now calculate here Vx dash, moment at C, and this reaction Vx. So first calculate shear at this point. So this point shear is this 10.625 kilonewton. Arrow is downward, so shear goes downward. See this 10 kilonewton. Between this point to this 2-meter distance there is no load, so horizontal line. This 10 kilonewton goes downward. That means minus 625 here, 10.625 minus. So minus 10.625 minus 10, it is minus 20.625 kilonewton. So again no load in between this. So and see here, see this CY reaction upward. So for that BC beam, so I will tell you this also. Just consider this CY reaction value is 20.625 kilonewton. So here see 20.625. So our calculation is correct. So this is shear diagram for this. Now calculate. Now calculate for this CD. So see, every action there is equal and opposite reaction. So here it is 20.625 downward, and near to this beam BC it is upward 20.625 kilonewton. So that's why here see this 20.625 kilonewton comes here like this. This goes upward. So here Vx dash is 20.625 and correct arrow is like this. Yes. Now and see here for CD, see this. Okay, we will consider movement later. See at point D shear is 0 and at see this beam like this, C to D. Solve it by clockwise. Solve first A to B, B to C, then C to D. First is C, only axial load. So shear is 0, no shear. At point C also no shear, for that beam also no shear, and D also no shear because there is no load. Now calculate moment. This is shear. Now first draw shear force diagram. So for that element AB, here it is 25.0 and it is positive. So draw positive value away outside. So this is 25 and 0. Now for that point BC, it is negative. So negative inside that frame and positive away outside that frame. Negative 10.625, 20.625, 10.625, 20.625, again here 20.625. And for that CD, no shear. This is for that bending moment. So your shear calculation is complete. Now draw BMD at point A. So see here BMD. This is ABB. At point A, movement is 0 because there is pin support. At this point, see this load is minus 5 into distance is 2.5 into 2.5 upon 2. It is minus 62.5. And load is UDL, that means it is parabolic curve. Minus 62.5 kilonewton meter. Now calculate bending moment here. 5 into 5 minus 5 into 5 is concentrated point load and into 5 by 2 where it is act. this is anti-clockwise, so again minus 5. So see, consider this AX also, this AX reaction. So AX is 25, so positive 25 into, this is first, calculate at this point moment, that means at this point. So consider this A by AX is clockwise, value of AX is 25 into this to this distance is 2.5 meters, so 25 into 2.5. Now consider this UDL. UDL is 5 into 2.5, and it is anti-clockwise, minus 5 into 2.5 into 2.5 upon 2, 46.875 here. Now calculate movement at this point. This is parabolic curve. At a distance 2.5 meter. Now calculate for this point. So positive AX, positive 25 into 5 minus 5 into 5 into 5 by 2 is 62.5. Unit is kilonewton meter, here also meter. And value is, see, positive 25 into 5 minus 5 into 5 into 5 by 2. Here it is positive. Positive 25 this is also positive. At point A, movement is, see this movement, 62.5 is clockwise, positive. So here also 62.5. kilonewton meter. AY reaction is downward 10.625 kilonewton. and here 10 kilonewton load at a distance of 2 meter. Now calculate moment here. At point A it is 62.5 positive. At this point moment is positive 62.5, and this 10.625 is downward, so an anti-clockwise to that point, so minus 10.625 into 2, so 41.25 here. Then 62.5 here, 41.25, and at this point minus 10.625 into 4 total distance. This is clockwise positive 62.5. Again this 10 kilonewton C minus 10 into 2 is 0. So here it is 0. So this is also positive movement. 62.5 and 41.25. We will check this in STADD Pro software also. Now here see, always calculate here bending moment shear force from this C to C, from C to D, like this. Here also 0 kilonewton, because C at this point here it is 0. So this is shear force, this is bending moment. Now check this in STADD Pro software. See, here there is one mistake. This curve is like this or like this. Movement curve, this curve. So for that, remember V is equal to, dV by dx is equal to minus m minus x, that means loading, and dm by dx is equal to V. So V maximum, then this slope is also maximum. See here, V shear is maximum, then this slope is also maximum here. See here, slope is 0. If we take like this slope is, so we will see this in STADD Pro software, how this, it's per my, see this in STADD Pro software. I think this shape is correct, because see, slope is maximum here. If we draw like this, and see, slope is less here, that's why this shape is correct. Slope needed to be maximum. STADD Pro here, see STADD Pro BMD shape is different because STADD Pro considers positive as negative and negative as positive, because hugging moment in STADD Pro is positive and sagging moment is negative. Our manually calculate positive, that means STADD Pro negative. This is like this. Our manually calculated negative moment, that means STADD Pro is positive moment. So that's why STADD Pro consider this red color BMD is in inner side of that frame. So new unit is metric, create first consider one node is 0, second node is at a distance of 4 meter and vertical is 5, 4 and 5. So view, go to utilities, beam tools. First I need to draw some beam. Now go to utilities, beam tools, dimension beams, display. See our dimensions are 0 node, this is 4 meter, this is also 4 meter. Why this is 4.125 shown. Node tools, node to node distance. See this is 4 meter, this is 4.123 meter, this is 5 meter. So here this y is yes 5, this is 5. Yes, now it is correct. Remove node to node distance, again see dimension beams, display. Now see it is correct. Give some properties for errorless calculation. 0.23 by 0.25. We are solving our SFD BMD only for that 10 kilonewton and that UDL 5 kilonewton. We are not interested to solve for that rectangular dead load. Only for errorless calculation we are doing that. Concrete material, etc. All this. Support is one is pin support, one is roller support. For roller support only vertical reaction comes, all others are releases. So now go to loading, load case details, and loading type is live load, add close. Now first this 10 kilonewton concentrated point load, go to member load, concentrated force minus 10, because see this device direction is upward and our force is downward, that's why the minus sign comes, and magnitude is 10 kilonewton. Add close, add need to provide distance also, this is 2 meter distance from that point B. So change close, take, use cursor to assign this. Yes, it is correctly applied. Now live load, now UDL uniformly distributed load, member load, uniform movement, uniform force. See this GY direction is upward, so our force is in X direction, it is positive 5 kilonewton per meter. So up, see here, see this corner, this x direction is like this, so our frame is like this, so UDL is here, so this x direction, see x direction, so positive like this. Select that beam, then see add assign to selected beams, assign. So this is also correctly applied. See scale, right click, labels, scale, and distributed force, reduce the scale. Then for distributed force, you click here, apply immediately. Yes, it is correctly applied. Now analysis, click here, define command, all, add, close. Now run analysis. Structure has been modified, save. See how STADD Pro calculate all of this. See this, joint coordinate, member element, stiffness matrix, global stiffness matrix, how we calculated manually and how STADD calculated. See this, reading member properties, all this. First, see deflection. See here, due to this UDL, this deflects like this. Here pin and here rollers, so more deflect like this. Now see reaction. See 20.625. Our is also, see here, CY is our 20.625 and X is 25 and Y is 10.625. See here 10.625 and here it is 25. So reactions are right. Now see BMD. Now annotate beam results, shear, maximum, midpoint, end. Now see, this is exactly match with our manually calculated. See, this is 25, this is 12.5, this is 25, and at here point 0, this is 10.625. See, this is 10.625, 20.625 minus. So shear is exactly matched. So our manually calculated and STADD Pro calculated both are matches each other and both are correct. Now go towards movement. I tell you that STADD Pro movement is negative, that means our manually calculated positive. STADD Pro movement is positive, that means our manually calculated negative. Signs are changed manually and STADD Pro calculator. So see this, see this SFD is in inner side, that means negative. Go to beam result, annotate, okay, close. First see values, 0.46.825, yes, 62.5, yes, 41.25 and here 62.5. So now it is correct. Now see this slope, it is like this. So this is like this. See which slope is maximum here. See this or this. When shear is maximum here, slope need to be maximum here. Just see this beam like this. This is, we take shape like this. Slope is less here, but if we draw like this, then slope is more. So this shape is correct. See this. Like this. So remember this. This V maximum, then slope BMD slope maximum. So see here, V0, shear 0, see slope. Slope is also 0 there. So that is how frame structure SFD and BMD calculated. Thank you very much.